we restart, Abhishek? We are now 11:07. So I will share my screen. Okay, good morning to all of you. Wonderful day today. In Bangalore, we are celebrating Ayuda Puja, which means you worship all the tools and machineries that you use. So it's a public holiday in Bangalore. And we had a very heavy rain yesterday and wonderful weather today with a little shiny. And today, the 24th of October, we have a wonderful subject for the day, passive fire protection. And this is a 3 series webinar presented by Thomas Bell Wright. And you could see that the first series, the Façade, implementing fire safety and performance on projects. The second series will start on 7th November. What is passive fire protection? Understanding fire safety of building. The third and final series, practical implementation of fire safety strategies using resistance and reaction to fire. Those who develop the ability to continuously acquire new and better forms of knowledge that can apply to their work and their lives will be the movers and shakers in our society for the indefinite future. The quote from Brian Tracy. This is our 17th knowledge webinar series by Blue and Gray. It's our continuous effort that we need to keep sharing our knowledge because I strongly believe in three principles in life. First is all about learning. The second part of our life is all about earning. Then the final principle is giving. So learning, earning, and giving. So I always believe the more you give, the more you get. I am the son of firefighter and almost 33 plus in the field of fire and security industry. Very passionately going around preaching on the life safety and security to make our nation a Surakshit Bharat. And let us see how far we from making our country a fire safe. I would like to place some few statistics for all of you to understand. As per the NCRB report 2018, as many as 12,748 people died in 2018, which means that around 35 Indians die in every day due to fire. Every fifth fire-related death in the world in 27 took place in India. 58% of fire reported from home. Study says kids under 5 and adult above 60 are the biggest fire victims. 641 fire accident call, that's a fire call to the fire station per day. So we are ranked 103 when it comes to safe countries in the world. And when you look at the construction field, there is almost 35 deaths every day due to occupational hazards. We, as an Indian, it's our responsibility to make our nation safe. It's not only the government or the fire department or the police department to keep our nation safe. It is each one individual responsibility to make a safety a way of life. I'm sure you will agree with me on this. And if you see National Building Code 2016, Part 4, which talks about fire prevention, life safety, fire protection, it covers the requirement of fire prevention, life safety in relation to fire and fire protection of buildings. The code specify occupancy-wise classification, construction aspects, egress requirement, and protection features that are necessary to minimize danger to life and property from fire. It specifies the demarcations of fire zones, restriction on construction of building in each fire zone, classifications of building based on occupancy, types of building construction according to fire resistance of the structure and non-structural components, and other restriction and requirement necessary to minimize danger of life from fire, smoke, fumes, or panic before the building can be evacuated. So today's subject is importance of fire safety, passive fire protection. Unlike active types, passive fire protection system never seek to extinguish the blaze. Instead, the passive fire protection role is to contain the fire to its point of origin and prevent the flame and smoke from spreading throughout the building. In National Building Code 2016 highlighted the use of and the need for the passive fire system in building and structure. As I said in the beginning, the topic for the day, facades, implementing a fire safety and performance on projects. This is presented by our good friend, an authority on the subject, Abhishek Chabra. Abhishek joined Thomas Bill Wright in 2013 and has been the driving force behind the expansion of fire compliance activities. He has been advocating the need for the compliance to standards for improved safety and quality across industry for most of his 18 years of experience. He has a vast experience of how conformity is realized across supply chain of several industries, including consumer electronics, industrial, renewable, and building products. He has been writing various articles and presenting at various forums about how a mandatory and voluntary quality and safety compliance are realized. He also drives a blog and a LinkedIn group called Gurus of Testing, Inspection and Certification, www.tic.guru, aimed at expanding an understanding of conformity across the world. He is a member of IAS Technical Advisory Laboratory of UAE and also is a code contributor for UAE Fire and Life Safety. Ladies and gentlemen, we have a very esteemed speaker with vast experience and experience in writing codes and also ensuring compliance is made or met. I welcome Abhishek Chabra to speak on the subject, which is very passionate to him. Over to Abhishek.
Thank you very, very much, Dominic, for a wonderful introduction. I am, as you said, very, very passionate about compliance. This is a field which I love. And since the last 7 odd years, I have been doing extensive efforts in increasing awareness about passive fire protection. One of the key areas of our company has been expanding ourselves and expanding the understanding of a lot of people around the world on matters related to facade fire safety, as well as performance of facades. So without delaying, I'll quickly get on with today's subject. It is a subject which is very close to my heart, and I have been talking about this subject in several countries, not just the MENA region where I have been talking at conferences, educating consultants, authorities having jurisdictions, but I have spoken at several forums internationally in Society of Fire Protection chapters in London, in Spain, in New Zealand, and the list goes on. And today I'm very excited, very happy to come back home, talk to almost my family, people in my country, because it is a subject which is very, very important, often very, very misunderstood. So let's today talk about this subject. And I will begin with giving everyone who is joining me today from across the country, despite the fact that we have puja in lots of places and people might be busy. And I'm thankful for everybody to come in and listen to me. I'll give a quick introduction about our company. Our company's quarter of 25-year-old company. We started off doing curtain wall testing. As a short video that is playing on your screen, you will be able to see. This is where subcontractors build mock-ups of existing projects and install systems to validate the design elements. About 10 years ago, we entered into doing fire testing. We started off with doing fire resistance testing using a 3-meter by 3-meter furnace. And we added some small scale tests like the one that you may be able to see on your screen. This is a Steiner tunnel or an American test called ASTM 84. Below, you can see the 3-meter by 3-meter furnace in a test. In the last 5 years, we expanded extensively to support the problem related to facade fires. We added a slew of small scale reaction to fire tests, which I will of course talk in great detail through the course of this session. And we also added the large scale fire propagation tests, the NFPA 285, which is the American approach to fire safety of facades, as well as the British standard, the BS 8414. And I'm proud to say that we are probably the only lab in the whole world which is testing to both American as well as British and European norms when it comes to facades and fire safety. And not only facades, we have done an extensive amount of investment in testing laboratories related to passive fire protection. We currently have 4 fire resistance furnaces. These furnaces are as small as a meter cube, 1 by 1 by 1, and they go right up to 4 meters by 5 meters vertical and a 4 meters by 5 meters horizontal load-bearing furnaces where you can test everything ranging from intumescence to coatings to fire stops and so on and so forth. Dominic has done the needful. I'm opening a small poll, which you can probably already see on your screen and probably on my screen as well. Please, I would love to hear your answers so that we have an interesting session today to understand how the listeners are, whether people who are attending the session today, do you know us, have you known us or not, and so on and so forth. I will then delve into the details of the subject. I'll give another 10-20 seconds for the attendees to just quickly answer the poll questions. Thank you very much for answering these questions. I'll jump to the subject of cladding fires. Many of you are familiar. You would have seen lots of videos, lots of news items of big cladding fires happening everywhere in the world. The problem of cladding fires is twofold. There are 2 areas which are very, very important to know. The problem exists in hundreds of thousands of existing buildings which have been built a few years ago, or maybe sometimes much longer ago. And at the time of construction, the problems were not known, the materials were not known. All the knowledge that we have gained now today was not known at that time. So we have a challenge that how do we really deal with these existing buildings? And of course, the problem related to new construction that is either happening right now, or construction that is being designed or will be designed in the future. So I'll give you a brief overview of how we as a company and me contributed to this in many, many ways. I start off with explaining that the NFPA, which is the National Fire Protection Agency from the United States, they have a research foundation. They came up with a very, very interesting tool. They wanted to develop a risk assessment tool. This tool allows anyone in the whole world to assess the risk of their building. Anybody ranging from a facility manager or a building owner or an authority having jurisdiction, you can use this free tool from the internet and input data about your building and arrive at a risk rating with respect to facade fires. This tool, which is called the Effect tool, was developed by a company called Arup and supported by Johnson Hughes from United States, as well as Thomas Bell Wright, who was the technical advisor to the project when it came to fire testing. We contributed massively in helping the development of this tool, which is being used worldwide today, from United States to Europe to Middle East to Australia. We also did a lot of work in supporting authorities around us. We supported the development of the new revision of the UAE Fire and Life Safety Code of Practice, which combines and brings together a very good set of requirements for several different facade types and cladding materials, an approach which has been lauded and by Europe, US, and people around the world. We supported SASO, which is Saudi Arabia Standards Organization. We helped them extensively in develop exact criteria related to fire safety when they were revising and coming up with a standard specifically for aluminum composite panels. Even though we are a lab that has been supporting lots of certification bodies around the world, we started and became a certification body ourselves with a very, very strong focus on the industry and manufacturers related to supplying materials for facade systems, cladding systems, and ensuring fire safety. I will be talking through the course of the session on how hundreds of manufacturers who have listed their products for their fire properties on our directory not only benefit by being able to instill confidence among buyers, but also our certification directory acts as an extremely good database of how different designs which are used for facades and cladding systems can be proven to be compliant to fire safety norms, which are very, very stringent around the world. And for the existing buildings, we went ahead and undertook a large R&D project. There is a company fairly known in the world called Johnson Controls. They developed an extremely innovative, state-of-the-art solution to tackle the problem of fires on existing buildings. They developed a system which will proactively detect a fire on the exterior surface of a building and automatically use an active fire suppression system to bring this fire in control. People who are close to the subject of ACP fires or big facade fires know that it is difficult for fire tenders and people trying to control a fire to reach the site and control a fire, which often goes and engulfs the buildings very, very quickly. So in our laboratory, we built a 25 meters by 35 meters wall and added a slew of combustible cladding material on the wall. And as you may be able to see on your screens on a small video snippet of how this active fire suppression system is able to control these fires, So we were very pivotal to help Johnson Controls finalize their product, as well as demonstrate and make it functional, and to showcase to the whole world how this systems works very, very well. The system is in final discussion, then you will probably see this getting deployed in some of the buildings in probably Australia and Europe soon. So with this as a background, and with a very important discussion, the discussion which will tell you about how to achieve fire compliance for buildings that you may be designing, buildings that may be in your control, buildings that you probably are taking care of. And before I talk in great length, and I would like to talk very code neutral, I would be talking about standards and codes around the world. But before I do that, and before you understand, it's good to know almost the basics. I am sure a lot of you would have heard about ASTM, NFPA, and various standards and codes. Let me begin with explaining what these really mean when we talk about these. What is the power of these? The National Building Code, very well known to you in the country, and with great efforts from the likes of Sanjay Pant and the whole team in BIS and other professionals across the country who were heavily involved in making sure that the code achieves. And the last 2 years that have been spent to make sure that the code is reaching all the jurisdictions across the state. What does this code really mean? A code like the National Building Code, or the UAE Fire and Life Safety Code, or the International Building Code of the United States, is a code of practice. It is something which is a recommended good practice, which is currently undertaken by competent and consensus practitioners or professionals. It means that a document that has been arrived at by learning from hundreds of thousands of accidents and incidences and past experiences in learning from people and projects around the world has been all squeezed down to arrive at what is the minimum requirement for a slew of buildings, types of buildings, and occupancies. Such a document lays down a methodology, lays down the minimum requirements that should be followed for people who are designing and implementing a certain goal. The goal in this case being the building code, a code which defines how to make sure that buildings in the country perform on various aspects, including, of course, the chapter 4, which is fire and life safety. How are these implemented across the world? We use another kind of standard, which is called a method. As an example is the NFPA 285, the National Fire Protection Agency, who published a standard test method called the NFPA 285 for testing fire propagation characteristics of cladding materials. What are methods? These are highly prescriptive documents. They set out an agreed way of measuring, testing, or specifying, and what is reliably repeatable. And the key word to know for test methods or methods in general is repeatability. Unlike codes of practice, test methods are having a prime goal to ensure repeatability, which means a product brought to a laboratory, a specification written in a contract will trigger and talk about repeatability irrespective of the circumstances under which the test is being done, or so on and so forth. I then move to what is called guides. Some of you may have heard of ISO 17025. It is a standard used for setting the general requirements of competence for testing laboratories and calibration bodies. These guides, and there are several of them, They are published to give a very minimalistic, not very prescriptive, but an advice which reflects the current thinking and a practice how to do this effectively. As an example, the ISO 17025 will lay down some minimum guideline methodologies, will advise laboratories to ensure that how to ensure that the tests which are conducted are repeatable or not repeatable. With this as a background, and I'm sure you have a much better understanding of what is the intensity, what is the use of codes, methods, and guides. Let's look at the problem at hand, the facade fires. I'm sure a lot of you have studied, read, and may already be aware of a good background of why these facade fires have been happening. I'll give you a background again, just for the purpose of revision. Many decades ago, the construction that was done for what was called high-rise buildings, maybe 60, 70 years ago, was done using thick load-bearing walls. The floors were laid with the support of these thick load-bearing walls, and these load-bearing walls ended up performing lots and lots of functions. They not only supported the load of the floors, they also acted as very good barriers between the outside and the inside world. They were able to provide thermal gaps, thermal breaks, weather resistance, water resistance, and even building movement. And at that time, in that era, these thick walls were, of course, acoustically very well as well. If you remember, or if you have been to some really old buildings, some forts, some palaces, you would notice that the interiors are often very cool, very contained. They are away from the outside world. What happened in the decades that came by after this was a massive change in the technology. These changes in technologies allowed builders, contractors, architects, everybody to design high-rise, very high-rise buildings, not on the basis of load-bearing walls, but a contemporary design. This change, which has been evolving over the last few decades over and over again, gave a massive amount of growth and also gave a very good platform for people to design how buildings look like, ranging from relatively low cost, quick to deploy options. You may be aware or have seen the boom of glass buildings, what is called curtain wall systems, a glass and aluminum frame, which could effectively be manufactured in a factory, could be brought into the site and almost like Lego blocks can be put in place, bringing down the costs as well as making the deployment very efficient. But it does not stop here. It goes on to help everyone, town planners, architects, to design buildings which look extraordinary, which look out of the place. People want to design buildings that can blend in with the city or stand out in the city's architecture. These developments provided a massive amount of creativity for people to come up with expression where buildings represented something. But what were the functions that were of the big, thick load-bearing walls? These functions then eventually got divided. Now, designers, architects, engineers had to come up with a system that fulfilled all these functions, functions which were originally taken care by one thick element. Now, how do we fulfill all of these functions when we want to be fast, we want to be quick, we want to be very, very cost effective. Well, R&D, manufacturing facilities around the world, and the World Trade Organization, who allowed the supply chains to open up. Our country in 1993 opened, and so many materials from all over the world could come in. Designers, subcontractors, facade consultants had the freedom to bring in materials from different parts, and design and engineer a system that will fulfill the requirements related to what those thick load-bearing walls were able to do, which is great because now there is flexibility and you can almost engineer with the help of materials from here and engineer a specific solution. Where is the risk then? Well, the risk is something that is very, very evident in the world that we live in. What we see on our phones, in brochures, in advertisements, is this what you get? How often is this a real problem? What you see in front of you, as simple as going and buying a paint, which when gets painted in your house, you say, oh, well, maybe this is not how it was, right? So I want to check from you. I don't know how many of you have actually experienced something like this, where you order something and what you get is something else. In today's world and in today's time where a lot of shopping has been happening online through e-tailers, we are looking at buying things, and when they reach, they might not necessarily look and feel and perform the way they were supposed to perform and we thought they will. This problem is dealt very, very effectively in many types of consumer products, which you are probably very, very familiar with. So let me quickly open a small poll question for you to take an opinion from you on how you see and you think that these situations are handled. Have any of you witnessed a product recall? I remember when I was in India many years ago, Nokia batteries were recalled, and it was probably one of the biggest product recalls that I had witnessed in my life. What is the situation with you? I would love to hear. Have you returned a product in the recent times? Probably you bought something from an e-tailer. I know that in India, a lot of shopping, or not just India, but almost all over the world, a lot of shopping has been happening through the internet. The pandemic has changed the demography of how shopping is done. Let me hear from you how this has been for you, everyone who is listening to me across the country and has tuned in. So, as a lot of you understand product recalls, you have returned products, you know how product recalls really work. But how exactly does this concept of product recall work in the construction industry? I don't know if you have ever wondered or come at a situation where you realized that the building that was constructed has some materials, some components, which have not only been procured, but also installed. What do you do now? How does the government help? Does the government help? Who can help? Very, very sadly, the repercussions are very, very bad and often outside the control of the stakeholders. if you are procuring or buying or renting an office. The people who were involved in designing, constructing the office are very, very far away. Accidents, damages, fires, claims, fines, reputation damage. The list is extremely long. I would not delve a lot into this. We are familiar with this. There are people who are from the insurance industry who are also listening in. And many of you are aware of these repercussions. Today, I'm going to talk to all of you and talk about some simple and very, very easily implementable methodologies. Things that once you learn, you can ensure that as a stakeholder, you can ensure that fire safety and potential damages in existing or new buildings that are being constructed do not happen. So let's talk about 4 very key steps that are undertaken from the time that the elevation gets visualized in the office of an architect till the time that the building envelope is actually fully commissioned. It starts with selection of materials, and a key part of selection of materials is to know, write, and ensure what are the properties or the fire properties of materials that will be used to design a facade system or a cladding system. And this, of course, takes me to a very important aspect, often known in some circles, that what is the resultant property of a facade system. The property of a material behavior and a system behavior is often very, very different. When 15 different materials are brought together in a configuration, in a defined configuration, their systems behavior as a whole system is often very, very different from the constituent elements. How they would behave when it comes to fire is something that needs to be tested and validated. And once such tests are done, tests which will check how the reaction to fire behavior of one material behaves and interacts with the reaction to fire property of the material adjacent to it. Is there a material that may take a very short time to ignite very quickly, may not have enough energy to burn, but just enough to ignite the adjacent material, which was very difficult to ignite, had a low ignition temperature, came across as very, very safe. But when the second material gets ignited, there is potentially a catastrophe that can happen. So not only that you need to make sure and validate the design and behavior of the cumulative system, you need to check and ensure what are the materials that are being delivered to the construction site. You could have chosen great material. You could have done a good validation of design, but wait a minute, what is happening at the construction site? How do you check and ensure that the materials are the same as they were declared to be in the first place? And then once you do get the assurance of these materials, you need a very, very stringent watch, a watch on ensuring that the materials that came in are getting installed in the same way as the approved system, the design which was validated, and lots and lots and lots of money was spent to ensure that this validation is in place. So let's start with the building blocks. A lot of you would have seen test reports, and a lot of you probably already rely heavily on saying a manufacturer has submitted a test report that my product is fire safe. I'm going to talk a little more about what this fire safe can potentially mean. What is fire resistance? What is retardant? Ignitability? There are so many properties that often get thrown with the basis of what? Fire test reports. What are these fire test reports? And the most important part, how do you establish a link between a test report that is submitted as a part of, let's say, a project submittal or a brochure? How does that link with the material that eventually reaches the site in a packaged container? How many tests were done before getting that test report that was given to you and submitted? How were these tests done? In what kind of laboratory? Were there several failures behind it? Was the laboratory capable of doing these tests? How do you validate this laboratory? And my favorite question, so many people ask me this question, that Abhishek, I have a test report and it is valid for 3 years and it is the 4th year today. Can I still use this test report? Unfortunately, I feel very, very sad when such questions get asked. The validity of test report is an often misunderstood concept. A test is done on a sample which is produced and submitted to the test laboratory for that given moment. The sample or the submitter of the sample is very, very well aware that this sample is going to the test laboratory to get tested. It is almost like a bride and a groom going to meet each other. They will always put their best foot forward. And the test, when done under laboratory conditions, is only valid for that sample. There is no validity because the link between the supply of material, that material, which was manufactured in the factory and then brought to the laboratory for a test, was just that. The validity of test reports, often written on test reports, is keep in mind that standards, test methods, as defined earlier, are up for revision, often in a cycle of 2 to 4 years. Test methods will get revised. And also, it is impossible for any product manufacturer to maintain exactly the same supply chain of raw materials. Raw materials change. So keeping all those variables in mind, there is some validity as a process set by some test laboratories, not all. Laboratories in the swim, like ours now, do not really issue a validity to a test report, just keeping this in mind for people to know and understand that a test that was conducted, the report of the test only talks about the behavior of that sample alone and not the supply or not the product that is produced many months, many weeks, many years later sometimes. So how exactly does this loop get closed? Many of you might already be familiar with the concept of certification and listing. Certification and listing is a process whereby a third-party body, often using a guideline document published worldwide, ISO 17065. This guideline document will tell how all these certification bodies, third-party certification bodies, will come up with a process which is repeatable, a process to ensure that the manufacturing location, which gets certified and listed, is able to produce the product repeatably. What you see on your screen is a 4-step process, which is often very common among all certification bodies in the world. They will start with taking a look at the manufacturing process at the manufacturing location. They will understand the manufacturing location's process and create a traceability of all the products that will be tested. Then these products are tested in the laboratory, often more than once as well. And once these materials comply to given test methods, these test methods could be checking the reaction to fire behavior like ignitability, combustibility, flame spread index, calorific value, fire resistance. There are so many properties. It could even be validating the acoustic or thermal performance of these materials. And once enough test data is available to ensure that the products that were manufactured at a given location through a manufacturing process that has been mapped by the third-party certification body is then audited. These audits are done regularly, sometimes up to 4 times a year, to ensure that the third-party body can certify, can give a certification mark, a traceability number to the manufacturing location. And hence, such manufacturers will put not only the certification mark of a third-party certification body, they will give you a certification number, which you as a buyer, as a specifier, as an approver, can actually validate. You can go online to the certification body's website. You can punch in either the name or the number or even the test method of the product and look up to verify, is the certificate valid? Where is the certificate issued from? What are the test methods to which the products are complying to? And often these listings capture a lot of details for buyers, specifiers, insurers, contractors, consultants to validate all these properties. As an example, you see a fire door, which gets tested for fire resistance. The certificate and the listing document will give you enough and more evidence for you to check at the construction site that is this the same product which was printed in the brochure or submitted as part of the specification document. And this brings me to a subject very related to facade systems and materials, which is a key difference between a product test and a system test. What is a product test? A product test is a test of reaction to fire properties or any properties of how a product, as an example, insulation material, ACP, cladding material, rock wool, foams, sealants. There are a plethora of items or materials who have their independent material properties. And then a system behavior, which is, as you can see on the screen on the right side, you have some mock-up fire tests, photographs of mock-up fire tests. System tests often validate design ethos. They check the concept of design. They check the concept of how several different materials behave when they are brought together. When they are brought together with defined dimensions, thicknesses, and sometimes air gaps as well. Let me quickly show you that when you see these certificates submitted to you in part of submission documents, how do you really validate these certificates? I'll show you with an example that you can see on your screen. This is an example of a certificate issued to an aluminum composite manufacturer in India. You probably are familiar with the name of this company. On the screen, you would see this certificate, which all of you can look up on the certification directory of our company, www.tbwcert.com. This certification directory details a lot of information which you can use not only to verify that the specifications that you are using are correct, but also the address from which this certificate is coming. And here, now you see the listing of a system test. A system test like the NFPA 285, which I will detail later. Such a system test listing will have a lot of information defining the design of the system. It will list down all the other components of other manufacturers how they were brought together, what were the details of the design, what were the air gaps that you see. And all this information is extremely important for you as someone who is designing another system for a building which you will be using. You could be validating the submission of a product manufacturer who claims that his material is fire safe. It is very, very important to know that if a given material manufacturer, like an aluminum composite panel manufacturer, if he has done a large scale test to prove or to have evidence that his, let's say, ACP will not go up in flames like some of the videos that you may have seen, this is the test. Well, yes and no, because you need to know and understand how that aluminum composite panel was designed into a solution and installed. Were there lots of other designed features to ensure that the oxygen gets limited to the fire that can potentially grow? What were the air gaps? What were the fire breaks? And there are a large number of design elements to ensure that the system behaves in a given way. From the hundreds of large-scale fire propagation tests that we have done in our laboratory over the years, we have seen materials which could be classified as per the European norms as per class B1, even B2, have actually complied with a large-scale fire propagation test. And on the other hand, we have seen materials which are often referred to as per a classification method as A2 in terms of limited combustibility, could be part of a cladding system that actually catches a big fire. So mind you, it is extremely important to know and understand this difference. There is material property of behavior. There is a resultant system property, which is of a specific design. This property is not everywhere. And why is this important? People who are familiar with facades and cladding systems would know that a cladding design or a facade design often has a large number of drawing details which define how the facade system will get implemented. Some of the complicated building facades have hundreds, sometimes probably even thousands of drawings. This is where you need a subject matter expert, someone who can understand and go through these hundreds of drawings and pinpoint to specific drawings. These are the drawings where those materials are coming together that can potentially cause a fire. How do you know? You know by the reaction to fire properties. But how do you really design and validate that the facade drawings, the elements which will eventually get installed on the construction site, they will not go up in flames like some of the horrible videos that you have seen? This is where the subject matter expert needs to compare several high risk scenarios of a given drawing with the submitted fire test reports of these mock-up that a manufacturer may say that, well, we have a test report as per a large-scale fire propagation test. My material is certified and listed in the certification body of so-and-so company. But if you are implementing a very, very different facade design, you could be sitting on a very, very high risk. And this is where you, as a subject matter expert, or someone like you right now, who has understood this concept through the course of this webinar will need to ask for evidence saying, what about my project? What about my design? Is my building's facade designs, are my building's facade design covered by that test report which is being submitted? Or do I need a different test just to get enough evidence that my specific system will not behave or will behave? Let me take you all to our laboratory here in Dubai and show you with the help of a quick video of how these large scale fire propagation looks like. You can see on your screen this large 25 by 35 meter wall that I was talking in some of the initial slides. I will shift to SketchUp because our drone photographer did not get the license to do a lot of drone photography, but I will switch to a SketchUp to show you our laboratory where we do these tests. On your screen on the left, as the video moves, you can see a place where we do these large scale fire propagation tests. On your left, you see the test rigs as per the British standard, the BS 8414, the test method that has been talked a lot through the course of the Grenfell investigation. And here at the center of your screen, you see the test rig, which is used to conduct the large scale fire propagation tests as per the American standards, the NFPA 285, also called as ISMA or intermediate scale multi-story test apparatus. Let's look at how these tests are performed. A subcontractor will come in and build a mock-up replicating the design of the project, exactly replicating how the exterior fascia material, like the ACP, my favorite example, and insulation material, fire breaks, gaps, supporting installation material, which could be gaskets, which could be fasteners. What are the types of fasteners? What are the air gaps? All these details are replicated. The NFPA 285 test goes up to great lengths to explaining that the joints, which can come between, let's say, two aluminum composite panel, should be above the window header. The window header is a place which here, as you can see on the screen, replicates a window that is either in an existing building or a window that can develop in case there is a building fire. You could have a situation where you don't have any buildings in a high-rise tower, but due to a fire that has broken out in a flow, due to the hot gases, you could have a break, a place where hot gases burst out of and create the often discussed and talked about the leapfrog effect. And what the window burner does is to replicate how the leapfrog effect or how the escaping hot gases or fire will interact with the whole buildup of the facade. These gases would go in between the air gaps as well as attack the exterior face of the system. And hence, only a given design, one specific configuration gets tested and validated through this large-scale fire propagation test. A similar fire propagation test is done as per the British standard. This test method is slightly different from the American standard, as you can see on your screen as well. There is an L-shaped mock-up, and there is a wooden crib which creates the fire as against a gas-fired burner set in the American standard. And here again, some different aspects are replicated. You have a L-shaped window, which means you have a L-shaped mock-up, which means there is a reflection of heat and flux that comes across because of how the fire can potentially grow. The British 8414 test is done in two configurations, part 1 and part 2, depending on the type of subframe and structure. And of course, this is a subject which I love, and I can probably speak for an extremely long time, detailing how these large-scale fire propagation tests replicate only a given set of situations or scenarios of a project. And this is where, as I said, we need to go back and assess and ensure that a given building could have so many different types of drawings and designs. So let us understand with this overview of how can you help. What is it as a role that you can play to ensure that these fires do not happen where you are? I'm going to open a quick poll. Dominic will help me open another poll, which probably is already on your screen, just for me to get a quick idea of who the listeners are as I continue your journey to understanding these tools slightly better, implementing these tools slightly better or much better, and ensuring, like Dominic says, you have to take a pledge that we ensure that such fires do not happen where we work. You can see the possible stakeholders that exist, and there is a bigger list that is there on the poll screen. We'll wait for a few more seconds for the poll to end, and I will then continue my journey of explaining to all of you on how you, as a responsible stakeholder, can understand these 4 tools to ensure that the cladding systems, the facade systems that you are designing or implementing or specifying will perform to the expectations that all of you have. Let us start with material tests. There is enough I talked about in the slides that crossed, talking about the link between a test report and what is called certification and listing. And I must impress upon each of you as a listener to know that there is a guideline document called the ISO 17025. We have India's NABL, the National Accreditation Board, which will accredit a test laboratory as per this guideline document, ISO 17025, which means that the test laboratory who submits a test report to you for any kind of evidence should have the capability to repeatably produce the results of the test, to demonstrate that they can do these tests repeatably. And as I talked about, the link between these test reports, which could be a test done somewhere, to a test that ensures and demonstrates the repeatability of performance at the site of the product that you will have tested. Let's look at these tests. What are these tests? For facade materials, the 4 key properties of reaction to fire must be kept in mind when you are choosing material that will all come together, behave and perform as a system that will bring about all those properties that a thick load-bearing wall used to provide 60, 70 years ago, and probably much more than that. First is ignitability. We all know things catch fire. lots of things catch fire. But what is the temperature? What is the environment in which a material will catch fire? And this may not always be very, very risky. If you imagine around your table in your place, you can see paper, you can see maybe a plastic bottle, and you will be sure to answer that the paper will catch fire more quickly than plastic, which means plastic and paper have different ignitabilities. But are both of them equally unsafe? A small piece of paper could burn very quickly and go away. But a similar size of a plastic material, and depending on the type of plastic it is, could take a little longer to actually catch fire. But then when it does catch fire, it may be a more combustible material, which means the calorific value of this material is higher. And the words calorific value and combustibility are often used in ways which is put forward as data by different test methods in different ways. So it is important for you to understand what test method are you using. The calorific value, which very simply put, as we all know in India, when whoever is eating sweets like I am, I love to eat sweets, the season is coming. Whatever has more sugar, whatever has more calories is probably more harmful, right? So there are some building materials which have a higher calorific value, which means these building materials have more to burn. And how does this relate to materials which we use in an everyday scenario? The amount of these high calorific value components of materials as part of the material will define how quickly a flame will spread across it. Simply put, easy to remember, how much sugar does your burfi have? It means that how much sugar and how the subcomponents or chemicals which have the capability to burn much higher are spread across the material. This will define the behavior of the building material, whether you're talking of a board, a magnesium board or a gypsum board, or you're talking of an aluminum composite panel, a panel that can have a core material, the core, which is a unique chemical formula of each manufacturer. What is the calorific value? What is the combustibility? What is the flame spread? Whether this catches fire quickly or not. And the industry and manufacturers will often throw you an extremely large number of data points. The European norms, in my opinion, having done so many tests as per American standards and British standards and European standards and so on and so forth, has evolved a very, very effective classification method, which is also used in the UAE Fire and Life Safety Code of Practice, the code which Saudi Arabian Standard Organization has published for ACP. This classification method classifies material as you can see on your screen, a non-combustible or nearly combustible material, A1, A2, and then right from B to F, it has a classification of how quickly materials can catch fire. But not only combustibility, it also classifies the amount of smoke it releases. And in several cases where you have plastic or plastic related components, it talks about a parameter called droplets. You can imagine that some plastics drip down when they burn, but some plastics also drip down burning, which means carrying the fire. So there are 4 different test methods: EN, ISO 1182, ISO 1716, the EN 13823, 11925. These are all different test methods which will test any given material and classify this given material to a classification. And while a lot of people may think that the European norm, which is the EN 13501-1, is a test method. It is not so. It is a classification method which will arrive at a table using data from a lot of tests. And these tests, how they are conducted varies depending on what the material is, whether they are homogeneous material or non-homogeneous materials, what is the substantial layer, how much is the substantial layer, the number of tests that need to be performed can vary. A typical example is the aluminum composite panel. Known to many, an aluminum composite panel not only has the aluminum skin, a color or a coating on top of the aluminum skin, but also an adhesive between the aluminum skins and the polyethylene or some other kind of core that exists between the polyethylene. And hence, there are several materials which are and need to be tested separately. The glue and the adhesive needs to be tested separately. The core needs to be tested separately. And a slew of tests needs to be done before someone can classify a simple material like an aluminum composite panel and say whether the material is combustible or not combustible. And as I mentioned, a test report should not be taken at face value. You must validate and confirm the certification and listing, because it is this certification and listing which will give you all the data you need to make sure that the decision you are undertaking is right or not. Under what combination and in what circumstances these materials have been tested in what designs. And again, I would bring your attention to the guideline document, which is ISO 17065. This guideline document defines how certification bodies will certify the product. You could have a manufacturer whose certification is conducted without doing any sampling. Just submit a test report with no traceability of how the product was actually made, where was it made at a given manufacturing location or just somewhere else, and a certificate is issued. So make sure if you are using a certification body, this certification body has proven capability of being able to do what it claims it is doing. And as explained in the same example earlier as well, it is important to know that a facade system is an engineered solution. Assembly tests need to be done to make sure and to check what is the resultant behavior. And these assembly tests need not always talk about fire properties. There are so many other properties, as I said, that need to be fulfilled and demonstrated by these exterior cladding facade systems. Just roll back your eyes and imagine the big, thick load-bearing walls of those palaces, which were built 80, 100 years ago. All that they were capable of, making sure that the wind and the water do not ingress inside the building, acoustic, weather, and a plethora of different properties that actually need to and get validated in projects here and everywhere else in the world. We could talk about impact tests, we could talk about pull-out tests, and the list goes on and on. Like the climatic conditions in India and many other parts of the world vary a lot, we also do what is called thermal cycling tests, which validates that the gaskets and those materials that expand and contract and behave differently when weathered. So thermal cycling can be done in the laboratory. So many things can go wrong. Many of you may have seen, if you live in big high-rise buildings where you do not necessarily have windows, these are closed buildings, the ventilation, the air-water infiltration can wreak havoc. You could have water coming inside the building, inside a compound. If you have a mall or an airport or a shop where water comes inside or the windows break down just because of bad pressure, things can really, really go wrong. Let me show you a quick video of another NFPA 285 test done to ensure and just to bring out the fact that the design and the implementation of the design is very, very important. And something very, very bad can also happen in a test. So how do you actually check and ensure with the help of an inspection that what you have procured, what you have ordered, what you have specified is something that is really coming on the site? Again, going back to the guides, there is a guideline document that has been published called 17020. This guideline document defines how inspection bodies can verify and demonstrate that the inspectors that they have on board are qualified to inspect what we are talking of. I will show you another example on your screen on how an aluminum composite panel manufacturer who is supplying ACP to the construction site will demonstrate this repeatability. If you see on the right on the screen, on the back of the aluminum composite panel, where the sheet, protective sheet does not remain, this is where you would notice that there is a ticker that runs. This ticker will talk about, let me show you. This sticker will have a number. This number can be validated on the certification directory of the certification body. And how this can be done is something which is very, very simple. I'll show you another video. You just turn back to the ACP sheet. You can see these numbers. Once you see these numbers, all you need to do is punch these numbers into the certification body's online directory. Every certification body needs to have an online directory. If someone claims to have a certificate which does not have an online access to the certificates, it is something that you need to be very, very careful about. So before I come to an end, let me do a quick summary of how all of you can be sure of and can ensure that there is a fire-safe cladding system. You begin with doing a risk assessment. Facade designers, architects, subcontractors, all the people who are in the system need to ensure that you choose the right materials as per the correct properties. Ensure that you have a certification and listing so that this certification and listing can be used at the construction site to verify that the materials that were brought in were right. Validate that the designs that were done, these designs have been validated through large-scale fire propagation tests, and ensure that you have a qualified inspection body. That brings me to an end to my presentation today, and it is up to all of you as different stakeholders that where you need to make sure that you do your stuff right and do not have a big flooding fire. Dominic, I leave the floor back to you. I will now go through the list of questions that have been coming and can start addressing them.
Oh, thank you. Thank you, Abhishek. It was a wonderful session, very detailed. I think all the audience participants would have seen the difference in the past webinars, and Abhishek's webinar is very, very clear and to the point on when it comes to the testing of material and the material that goes into the passive fire protection. And we have good participants. We have around 290 participants so far, and we have got some 9 questions to ask today. So I will begin the question from Manish Kandelwal. He's asking, 3 meter by 4 meter wooden fire test possible in your lab? 3 meter by 4 meter wooden fire test possible in your lab?
Absolutely. Absolutely. This is a test which is very, very possible, though I am not very, very clear, Manish, what is the kind of test that you're talking of, if you're talking of this test to be a cladding test, or what exactly are you trying to burn? I will just clarify to you and to everybody the kind of tests that we do in our facility. We have about 10 to 15 small scale equipments where we conduct tests of materials and their behavior. So we take anywhere from a small sample which is 5 to 10 centimeters or so, and we can test and validate the ignitability, the combustibility, the flame spread, the smoke behavior, the droplets behavior, as per as per the American standards, as well as the European norms. These are material reaction to fire tests. We also have 4 large furnaces where you can install a system or a material and check for the fire resistance, which means you can test and validate the fire resistance of fire doors, wall systems, partition systems, windows, dampers, as well as intermittent materials, fire stops, and so on and so forth, load-bearing beams and columns. And we can do fire resistance tests up to 3 or 4 hours, depending on the test standard applicable. We can test as per the ASTM standards, ASTM E119, NFPA 252, UL standards, UL 10B, 10C, ASTM E814, and the slew of European standards for partitions, walls, facade systems, and so on and so forth. And last, as you have seen some of the videos, we do the fire propagation tests, where you have a G+1 buildup of a facade system as per the British standard and American standard. We can do these tests. And if you want a custom test where we build a 3 meter by 4 meter wooden test and burn something, absolutely, we have a large facility. And like my colleagues joke around, we burn things for a living. So as a laboratory, absolutely, we can do a 3 meter by 4 meter test.
Yeah, Mr. Pradeep Mewada wants to know which section or part of American Society of Mechanical Engineers is applicable for fire safety of building. You have any idea, Abhishek?
I'm sorry, Pradeep. If you give me specific standard numbers, I can tell you. As far as I know, ASME standards are mainly talking about mechanical properties of materials and systems. I am not really aware of a building code as per ASME or a material test. It is likely that some ASME standard is pointing to another test method, and that is something that we can, of course, offer as a test.
Is it available in India? Like any standards are available in India? Is asking.
So in India, lots of standards are used, and how standards and codes are used. There is a direct link between the fact that whether you are a jurisdiction who has enacted a law to enforce the use of a standard as a means of protection, or you could be a developer or a builder or a buyer. You could be a company like Marriott or Google, who would say that my hotel or my building needs to have materials that needs to comply to such and such requirements put in place. So yeah, everything is possible.
Yeah, Dr. S.P. Anchore is complimenting. Excellent presentation, Abhishek. Fire safety installation is not a luxury, but is an essential thing. The building without proper firefighting system, name is like vehicle without proper brake. Why still awareness is lacking, Abhishek?
Well, what I am trying to do right now is to increase this awareness, is to make sure that there is more awareness about everybody, who are people like you and me, who are very, very busy doing our everyday jobs, who may not really understand the difference between what is a test report and what is a certification and a listing. Many people in the world around, I'm not saying India, in the world around, would say, oh, I have a test report, which means it is a blank check for the manufacturer to supply anything. just about anything. It's really unfortunate that what I say, the business of a business is to be in business. I have been in the field of compliance. I have walked countless number of factories, whether they are in Bombay or in Surat or in Pondicherry, people manufacturing all kinds of things, from medicines to machines to lighting to housing products. And believe me, the potential of chemical formulations changing, supply chains varying, decisions by choice, decisions by chance, there is a lot of gap that exists and can exist, not just in India, but everywhere in the world. So as a buyer, as a user, as a specifier, we all need to be very, very aware. We all need to make sure, just like if you buy a car or a cell phone, you compare specifications so long, but you need to know what you're reading, what it really means.
So that's great, Abhishek. What you're saying is when you buy an apartment or when you occupy an office space, make sure that the space is fully compliant. So we need to be aware whether safety is well defined in that area and the necessary safety equipments are in place. So going to Chandar Sethi, giving a suggestion that it appears speaker has drifted from the main topic of about fire. So I would like to clarify to Mr. Chandrasethi, it is all about the facade and the passive fire protection that we supposed to be addressed, and it is very well and very well explained and defined. But your suggestion is well taken, and we'll check that next time. We'll make sure that it's more carefully we address the subject that we are speaking. But with a very good suggestion, Mr. Chandrasethi. Moving to Dr. S.P. Anchuri again. Today, cloth, jewelry, and many showrooms are like almost a matchbox, almost zero window to wall ratio. Abhishek, what is your opinion about these envelopes having front glowing facade, all other side dead walls leading to death trap, having total artificial lighting and ventilation? How to save ourselves from man-made disaster? While Dr. S.P. Anchuri was saying, I still, suddenly I recall the fire in Chennai. I think the very large sari silk. I don't want to name the showroom, but it was, I think, must be around 7th floor. Absolutely zero windows, nothing. They had only one means of escape, no refuge area. The whole building, it happened in the night, the whole building just went into ashes. Nothing was left remain other than the concrete structure. But his question is quite valid.
So Dr. SP, I represent a laboratory and a certification body, and our role is to ensure that we provide the right tools to stakeholders who are buying or specifying materials. I or our company is not involved in designing or implementing a building code, but as an end user and as a citizen of the world, of the country of Dubai, all I can say is it all begins with awareness. It begins with people like you and people like me asking very valid questions to the world around us. If we have seen the fires like Dominic was mentioning, if you feel very, very rightly so that a shopping complex or a certain commercial building is a death trap, who stops all of us from talking about it? Who stops us in India in questioning the authority who has given a license for them to operate? We are lucky to be in a democracy, even though we are also unlucky to be in a democracy in many ways. But there are so many means for us to ask these questions, which only people who are related to the building, related to the geography, related to the city, related to the municipality can answer. And as someone who is a laboratory, who is testing products, is something that we may not be able to answer.
Okay, moving to Pradeep, what does certification provided by you to the manufacturer is for a process confirmation, validation, or for the product or sample, particular design that is manufactured, which have your certificate?
I think I'm very happy, Pradeep, you've asked this question. It's a very valid, very pertinent question. All certification bodies who are certifying and listing manufacturers on their certification directory. Someone asked, the link to our certification directory is www.tbwcert.com. These certification directories will always have an address, a physical location where a given product is manufactured. And this given product is certified to comply to specific parameters. So as an example, if we certify a insulation material, that this insulation material is class B material as per the European classification methodology, which means we have certified and audited the manufacturing process, the quality and the production control procedures, and we repeatedly do so to ensure that each time the material is shipped out of the materials gate, the materials which carries a certification mark somewhere on the product, if you pick up that material from anywhere on the site or so and perform the same tests in the laboratory, you will always get the same result for those specific reaction to fire properties. This is what the certification is about, and that's it. As a buyer, you will need to check all the other things in when you're using these materials. I hope that answers your question.
Yeah, Geeta Rao, she's asking, how can we get assurance that the product which is sample tested to meet certain standard is what we get in our project? Do we rely on ISO 9001 in that case?
I think the ISO 9001 is a system certification. It only relies or defines that the systems followed by a manufacturer are true or not. I will go back to one of the slides where I was trying to demonstrate or show how, if you get a material on site, just look on your screens. This is an example. Here is an aluminum composite panel, which is shaped and formed just about to be installed on a given building. On the back, there is a ticker tape, there is a number. You need to look up this number. This number relates to where and who is the certification body. And this is the tool which you as a contractor, which you as a consultant, you as an authority having jurisdiction like the fire department or the airport authorities, person who has been made responsible to ensure and check these things, they will need to go and verify, at least for products like these. So as an example, if you have a smoke detector or an alarm system, which is critical to life safety, if the smoke detector or the sprinkler does not work when there is a fire, well, why is the whole thing in place? So you need to check that these are certified and listed. Look up the certification number which is there on the product, and it always will be. And if it is not, that means it is not a certified product. It means you have no third-party assurance mechanism in place to make sure that yes, what the manufacturer is claiming or what the trader or supplier is claiming is true or not.
I think the Ramanathan Naganathan. So question is the same. What is the link to check the test report or in online? I think you answered that question in previous. So I don't need to revisit.
Yes,
or you want
I have written the link on the chat. I have written the link on the chat window as well.
Okay. Manish Khandelwal again, 2 hours wooden fire rated door with EI 120 minutes with 300 into 600 vision panel. So he's given the size of that door, which he said. So 2 hours wooden fire rated with 300 by 600 vision panel. So is what he's asking, whether you do the test for that.
So Manish, yes, we of course do the test for this, and I'm trying to correlate another message that you have written on the Q&A saying UL10C or the BS476. Probably, and this is my guess, you could clarify that what you're asking is that if you want to validate an EI 2-hour fire rated door with a vision panel of 300 by 600, whether you should use a UL test or a BS test. And I think this is a question that I may not be able to straight away answer. It all depends on your project. It depends on what is the building code or what is the fire and life safety code that was kept in mind while designing the whole project, and the test methods should align. And this is a question I always get asked: is a UL standard better or a BS standard better or an EN standard better? And I think it all depends on context, and you must understand the context. Just as an example, the British standard unfortunately has not been revised since the 1980s, whereas the European and the American standards have a very recurrent revision cycle, which means that they are able to capture all the changes that have happened in materials. They're able to take on and the learning from all the accidents that have happened in the past years and modify the methodology of tests. So I'm sorry, Manish, I may not have a straight answer whether you can use the UL standard or the BS standard or the EN standard, but your project, whoever has designed the fire and life safety plan, will be able to answer this question. You're mute, Dominic.
Yeah, a question from Swarup Naga. Steel material for columns are tested at what temperature as per IS code? How to make them fire resistance for 90 minutes?
Swaroop, as far as I know, the Indian standards have adopted the ISO standards, the ISO 834. I think it is probably part 5. The time temperature curve usually goes up to 900 or 1100 degrees Celsius in these fire resistance tests. And a lot can change. You could have a load bearing column. And depending on the application and the use, you would need to define how much load under which the test needs to be conducted. And how to make it fire resistant is a very unique question. It is like asking that how will my child pass the 9th class exams? I may not be able to have a straight answer. There are an extremely large number of material manufacturers who provide solutions like intumescent coatings and paints and so many other things that can help design a column to become fire rated.
Yeah, Nihali Das asking this question. Please say some points regarding fire resistant test of fire resistant paint on electrical cable. So the question is fire resistant test of fire resistant paint on electrical cable.
Sorry, Nihali. I mean, this is something we don't do. We don't test electrical cables in our laboratory. I am aware of these tests, what exists. I've seen some of these tests being performed. And the requirements are very different when it comes to electrical cable testing, because what needs to be validated is to ensure that there is no current drop, there's no voltage drop, and how paints and the kind of paints can enhance the fire resistance property is something that is very open-ended. It's very subjective. I will not have a straight answer depending on the type of cable, what is the kind of sheath, what is the material that is used, what is the environmental conditions. So that's all I can tell you, some points.
Question from Manimaran. What is the test method for existing door in a building which client claims fire door but has no certificate? So how do you know?
So Manivaran, you are in a tough situation, let me tell you already. We have helped an extremely large number of companies, specifically hotels, in the MENA region, which means in the Middle East, North Africa, Egypt, and many countries where people have plucked out an existing door along with the frame and ordered a new door and a door frame. And that door has been installed in our laboratory and burned down as per either the British standard or the EN standard or the UL standard to check and validate how they performed. If you do not have a label and if you do not have a traceability on the fire door which has been installed, in my opinion, you're already in a tough situation because anybody who has invested heavily in ensuring that their products are certified, listed, and are fire rated will always do several efforts to ensure that this certification and listing and labeling is visible on the door supplied. So, but yes, as a solution, many companies do this. Hotels, commercial buildings specifically, who are worried about the rents and who are worried about the potential situation of their buildings, they undertake tests from doors plucked out, and based on these test results, sometimes all the doors are replaced.
A question from Harish Natraj, a very interesting question. Beyond BS 8414, NFPA 285, are there any other full-scale test which is renowned and reliable? And are there any test facility in India?
So Harish, thanks for the question. There are about 25 known and published large-scale fire propagation tests in the world. FM does a few tests. Sweden SP Fire does SP 105. CSA has a standard method. Lepier from France, they have a standard method. There is an ISO method which does these tests. The BS 8414 itself has a few variations which are deployed in Malaysia, in Australia. And unfortunately, there is a big debate world around as to which is more appropriate as a test method to do. And trying to harmonize ideologies, thinking is an extremely difficult task. As far as the data available in the world around, the NFPA 285 and the BS 8414 are among the most widely used tests. And hence, there is an immense amount of data available in terms of whether these tests and test data from such tests is effective or not. As far as I know, there is no laboratory in India who does any of these tests. And I'm happy to say that we are not too far. We are almost like a flight from Delhi to Chennai. And we also have a very attractive situation. You can go up the Burj Khalifa and you can enjoy the lovely beaches of Dubai. And there's lots that Dubai has to offer. So we would welcome everybody to come and test with us in our laboratory.
Abhishek, many of questions are people asked, do you have a testing laboratory in India? I will answer, no. I'm sure very shortly you will have one.
Well, I hope we are able to do that. And I hope that the industry and the manufacturers, and more so the contractors, the consultants, and people, users of buildings, are able to drive an increased awareness about so many things that I talked about today. These are extremely important, and my heart aches sometimes when I travel to other parts of the world and see how awareness in the world around has driven such better standards of fire safety and security world around. And I am very confident that we all need to do is we all need to set our eyes on it and work aggressively towards ensuring that our country does not see any such big tragedies.
So Rajendra Kamal is asking, is it possible to do a test at the site? Okay, like leakage, facade gap between slabs, smoke seal, air around systemic. So he's asking, can we do a test at the site?
So Rajendra, yes, as far as the mechanical and weather tightness tests goes, air leakage, water leakage, smoke, etc., all these tests are doable on site. We have several projects where we have undertaken these tests at site. We have a team of my colleagues who have undertaken these tests in India, and we have a few colleagues who are probably working on projects here in India already for these tests. But the fire tests cannot be done on site. These are destructive tests, and a potential result can be catastrophic. So we do not get into that place.
Okay, Geeta is again a question on how do you verify, if a fire door manufacturer say that this product is as per so and so and which is certified and approved by Warrington Fire Research UK, what should we do to end user from a company? Is a reliable claim? How do we check the authenticity? So checking the authenticity of the product, how do we do that?
So Warrington Fire Research UK is part of Element. We know them very well. They are good friends. They are a very reliable laboratory. They're also a very reliable certification body. And I think if you saw some of my slides earlier, you should be able to understand the difference between a test report and a certification and a listing. And you must understand that a test report is evidence that a given material submitted to the laboratory performed. Now, a given material means a given fire door assembly that has been defined in great detail on the listing directory will perform only when all of those things come together. So if there is a manufacturer who has a hinge or a door closer or a mortise lock, which performed very, very well in a given combination of a steel or a wooden door and is part of a listing, then it absolutely does not mean that if that door closer is attached to any other door, it will become a fire rated door. A fire rated door assembly will behave only when that given assembly is brought together and is installed in exactly the same way. If a fire door is installed on a brick versus a fire door is installed on a gypsum board wall, well, there are different installations as well. So a fire door that performed on a type of a substructure may not always perform on another substructure as well. So it's extremely important to understand and see this holistically and not as components.
So Wilson Chitla is asking, very good presentation, Abhishek. Thanks for enlightening us. Fire hazard is same across the world. Fire has no religion, no caste. Why do we need so many standards? Why do we need to have one man ship claiming one standard is better than the other?
This is a wonderful question, Wilson. I have debated this question for so long in the last 15 to 18 years. The last 18 years, I have talked and sold compliance to so many different types of standards: American, British, European, American, Indian, and this boils down to human behavior. I'm sure that you might have been as a part of a debate that is the CBSE curricula better or is the ICSE curricula better? Which student will be more bright than the other? Is somebody who studied in an IIM better than any other institute, or so on and so forth? And I think this is the challenge of democracies everywhere in the world. It is very difficult for 40 people, 20 people, 10 people to align in their ideology. If you live in an apartment complex and if you're part of a RWA or a resident welfare association, you will see that it's extremely difficult for people to align on ideologies. So this is something that is an endless debate. If you talk to people who are in India, in Sanjay Pant's team from BIS, Sandeep Goyal, Shikre, so many people who've been part of the National Building Code, it has taken them a decade, more than a decade, to just align ideology, saying whatever is written in the National Building Code of India 2016 is everybody aligns to it. So I think it comes down to each and every individual's understanding of the first principle concept is 1 plus 1, 2 or 3. That's very basic. We all know it. So understanding these standards is important. Pick up anything that the world has proven and used than trying to reinvent the wheel. Unfortunately, all of these things take a lot of effort and time. If you look at the fire check door standard of India, the Indian standard long, long ago, and we have commented on the latest version, which is hopefully coming out soon, it is far, 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 far away from what the world is already doing. So it's better to adopt something which is clear, which is known, which is proven, than trying to say, well, I have a better standard and I can come up with it.
Hey, Rajinder, so we have another 5 more questions. We need to rush.
Okay.
The question from, not question, Rajendra Kamble. Thank you, Abhishek ji. Very insightful presentation. Do you do third-party test of facade
Of
only
course,
or
yes.
the building aspect also?
We focus mainly on the building envelope. That has been our core strength. So facades and curtain wall systems is something that we do test. It's something that we offer. We do it on site, we do it in the laboratory, and so on and so forth.
So Mehul wants clarification. We have already purchased a fire system equipped with IS and BIS regulations, but factory inspection given a written notice for purchase of fire equipment from LOA authorities and vendors. Now, what can we do? CO2 flooding system like goes near 1.5 crore almost. The question is still I'm not able to understand. We have already purchased a fire system equipped with IS and BIS regulation, but factory inspection given a notice to purchase fire equipment from LOA authorized vendor, but they already invested 1 crore almost.
Well, Mehul, I'll try to answer this question. You're probably trying to question the authority of a jurisdiction or someone who's asking you to do something. And I would recommend you to go back to first principle. Understand why are you implementing, what are you implementing? Whatever system it is part of fire and life safety code implementation, a process that has been laid out to ensure that what may happen and how to prevent what may happen. So you are tending to certain risks that may happen in a given building type. And I think you must put your mind to understanding the risks from a first principle standpoint and arrive at what are these methodologies, the CO2 system or whatever system that you're talking of. What does this really do? And how does it really help? And I think that will try and answer your question.
The last question is almost 1 o'clock, exactly 1 o'clock. We are on precious time. And the last question from Arish Natrajan. As a consultant, can I combine the result from EN 13501 and EN 135012? That is 13501/1 or EN 1350/2 to arrive at some conclusion on as-built assembly where full-scale test is not possible.
Interesting question, Harish. I'm not fully familiar with the context. The 13501-1 is a reaction to fire classification, which means it is a test done on a material and how the material would behave, whether it's combustible, smoke, droplets, etc. The 13501-2 is a fire resistance classification, typically done for partitions, walls, doors, and so on and so forth. None of these two standards can give you any idea on how a cladding system or a facade system would behave when they are subject to a potential fire risk. So I don't think you can achieve what you're trying to achieve with these two methods. I would love to answer your question in detail. You have my contacts on the screen. You will have my email address, and I'm pretty sure Dominic is going to send that to all the attendees as well. I would be very keen and eager to open a Zoom call sometime in the future to try and answer your questions.
Thank you, Abhishek.
Christoph?
With that, we come to the conclusion of this today's first series of passive fire protection. And ladies and gentlemen, we have the second series. What is passive fire protection? Understanding fire safety of buildings, series 2, coming on 7 November. I want to thank Thomas Bell Wright, international consultant, for partnering with us and sharing this knowledge, and wonderful speaker, Abhishek. Um, he love India. I'm sure he will do his best to increase the awareness on testing and various methods. And I'm sure they're going to be back to India one day with the test the lab here. And I wish everyone happy Dasara and stay safe, stay secure. Over to Abhishek, your last words, concluding statement.
Thank you very, very much to each and everyone. It is an absolute pleasure to have such a wonderful audience, all the people who are listening to. As I said, this is something that excites me. A lot of people truly believe that change can only happen when right people ask the right questions. And to be able to ask the right questions, you need to know where you are. As they say, if you want to know where you are going, you need to know where you are first. And it is my absolute pleasure to hold hands with Dominic. He's an absolutely passionate person, something that he's been driving as a cause. He truly believes that India needs to be safe. And this is something that both of us align in our ideology, that India needs to be safe. The last thing we want to see in and around us is people dying or getting hurt in fire accidents, or even loss of life, loss of property. So absolute pleasure to be here. I'd love to be here again, and see you soon in about 2 weeks' time. Happy Dussehra to everybody.
Thank you. Have a wonderful day.
Thank you very much. All right.
Bye-bye.
Thank you. Bye-bye.